is Ritanya and Nasugitan, and welcome to our channel Velocity Mind. Today we will be learning exercise 1.3, problem 7, 8 and 9 from the chapter Number Systems. Let's do it!
Hi everyone, today we are going to see 9th CBSE Number Systems Chapter 1.3 Problem 7, 8, 9 in it. Before going into the exercise, we need to clearly know that decimal is of two types, that is terminating decimal and non-terminating decimal. What is terminating decimal? Let's see with an example. When 3 is divided by 2, it gives 1.5 as an answer. That is, the digits after the decimal point will come to an end. This is called as terminating decimal. Then what is non-terminating? Here we can take an example. When 11 is divided by 3, we get 3.666 and it goes on. That is, the 6 continues. So, as the digits after the decimal point continues infinite times, then it is non-terminating decimal. Okay, understood? Okay, now let's see about the terminating decimal. The terminating decimals, all terminating decimal, not only this 1.5, all terminating decimals are rational numbers. Remember that? All terminating decimals are rational numbers. Okay, that is, it can be written in P by Q form. Does that mean all non-terminating are irrational number? No. Non-terminating are further divided into recurring and non-recurring. What is recurring? Here in this example 3.666, the 6 continues itself. That is, it repeats itself. So this repeating is called as recurring decimal. What is non-recurring decimal? Here in this example 7.34567110, the digits after the decimal point will not repeat itself. This is called as non-recurring decimals. Here, recurring non-terminating decimals are rational numbers. Non-recurring non-terminating decimals are irrational numbers. Understood? That is, if the digits after the decimal points repeat itself, it is rational. Okay? Here, terminating decimals are rational, non-terminating recurring are rational. Only the non-terminating and non-recurring are irrational. Clear? Now let's go to the exercise. Let's take the 7th problem. We have to write any 3 numbers whose decimals are non-terminating and non-recurring. Now let's see what is non-terminating and non-recurring. Yes, both non. I said when it's two non, that is two non-terminating and non-recurring, then it is an irrational number. Correct? Do you remember that, what I said before? Yes, non-terminating, non-recurring digits are irrational number. Okay? Tell me some example for irrational numbers. Yes, square root of 2, square root of 3, square root of 7, all are irrational numbers. What is the value of square root of 2? It is 1.41421 and it goes on. What is the value of square root of 3? 1.73205 and it goes on. What is the value of square root of 7? 2.64575 and it go on. So, these 3 rational numbers are the examples of 3 numbers whose decimals are terminating and non-recurring. That is, non-terminating and non-recurring. Okay, clear? So, in this question, what they mean by non-terminating and non-recurring? They are indirectly asking for irrational numbers. Okay, clear? Now let's go to the 8th question. Write 3 irrational numbers between 5 by 7 and 9 by 11. Okay, here we should find the value of 5 by 7 and 9 by 11 so that we can find the three irrational numbers between them. Now what is 5 by 7? Just do long division method. Okay. 5 is not divisible by 7, so I am adding a decimal point and putting a 0 here. 7 7s are 49, remainder 1, I am putting a 0. Now 1 7 is 7, remainder is 3, so I am adding a 0 to it. 4 7s are 28, remainder is 2, so I am adding a 0 to it. So I am going to continue this till I get a remainder of 5, that is the numerator. Okay, see here, 8 7s are 56, remainder is 4, I am adding a 0. 5 7s are 35 and the remainder is 5. So I got the numerator. Okay, now the 5 by 7 is equal to 0.714285. Okay, now what is 9 by 11? I am putting a decimal point and I am adding a 0. 8 11s are 88, the remainder is 2, so I am adding a 0. 1 11 is 11, the remainder is 9, I am adding a 0. Again 8 11s are 88, the remainder is 2, I am adding a 0. 1 11 is 11, the remainder is 9, and it goes on. So the value of 9 by 11 is 0.818181 and it goes on. Now we have found what is the value of 5 by 7 and 9 by 11, that is two rational numbers. So we have to write three irrational numbers, that is non-repeating, non-terminating numbers. Okay, the irrational number should satisfy two conditions, that is the number should not terminate and number should not repeat itself. We can write any numbers. Say after 0.714 we can write any number like 0.740, 7400, 74000. So here this is non-terminating and non-repeating. See, any number it is not repeating. Now let's take another example. 0.730, 7300, 73000. So it's up to you. You can write any number between these two. Okay. Now let's say we can take the number using 0.8. Okay. So 0. Okay, we can take any numbers. Okay, it's your choice, but it should be non-terminating and non-repeating. So I am taking 809, 8090, 80900. So this number 2 satisfies two conditions, that is non-terminating and non-repeating. Okay, clear? So I have written three irrational numbers between the two rational numbers by calculating their decimal values. Okay, clear? Okay. Now let me go to the 9th question. Find whether the numbers are rational or irrational. I have already said decimal is of two types. Terminating decimals are rational. Non-terminating and recurring are rational, but non-terminating and non-recurring are irrational. Remember 2n. If there is 2n, then it should be 2r. Non-terminating, non-recurring 2n, irrational 2r. Now, the first question is square root of 23. The square root of 23 is not a perfect square. Okay? See, 4 4s are 16, 5 5s are 25. So, there is no perfect square for 23. So, square root of 23 is an irrational number. So, if we find the square root 2, it will be non-terminating and non-recurring. Okay? So, it is not a perfect square. So, it is an irrational number. Okay? Do you agree with me? Okay. Now, what is square root of 225? Is it a rational or irrational number? Square root of 225 is 15. That is 15 squared is 225 and square root of that number is 15. So it is terminating decimal. So it is a perfect square, rational number. It is a rational number. Say 15 can be written as 15 by 1, and it is terminating, so it is rational number. Now let's go to the third question. 0.3796. So here this is terminating. How can you find? There is no dots after 6, right? So it is a terminating decimal. So obviously it is rational numbers, because all terminating decimals are rational numbers. Okay? How am I finding it's not a terminating decimal? Because there is no dots after the last digit after decimal point, that is after 6. So it is a rational number. Now let's go to the fourth question. 7.478478, and it goes on. So here we can clearly see 478 is repeating. From the dots we can conclude that it is non-terminating, but the digits after the decimal point are repeating, that is recurring. So there is only one non. It's non-terminating but recurring. So it is a rational number, because we know that recurring non-terminating decimals are rational numbers. Clear? Now let's go to the fifth question. That is the last question of this video. 1.10100 1000 10000 and 1, and it goes on. From the dots after the last digit, we can come to a conclusion that it is a non-terminating decimal. And seeing the digits after the decimal, I can't find any numbers set of numbers repeating itself. So it is non-recurring and non-terminating. So as I have already said, 2 non, so 2 are. Okay, it is an irrational numbers. Yes, correct. Okay, so here the digits are non-terminating and non-repeating, so it is an irrational number. Okay, what is another irrational number we have seen in that question? It's not a perfect square too. Okay, so with this, exercise 1.3 question 7, 8, 9 is over. We can see the next exercise in the next video. Okay, if you have any doubt, please comment below, and I'm here to clear your doubts. Okay, whenever you get free time, try to practice maths. Get a connection with maths. Okay, if you connect to maths will connect with you. Okay, meet you all tomorrow. Till then, signing off, Parveena Ramesh. Bye-bye.
Subscribe, hit the bell, leave a like. If you have any doubts, comment down. Signing off, y'all.